We
This
have
conference will now be recorded.
okay. We have Jay, Don, Nat, Richard. Richard, which company are you from? Hello, Richard.
Sorry, I had to step away for a second. What was your question?
Oh, sorry. Which company are you from?
Phoenix Technologies.
Phoenix. Okay, thank you. Yeah, thanks, Paul, for joining.
Just a
No
comment.
worries.
I would really like to be here more frequently, but I have a direct
Mhm.
conflict with another meeting normally, but it was canceled today, so I get to join you.
Oh, okay. It's very nice. Hopefully, you find useful for this meeting. I'm sure it will, and we need your input as well if there's any topic interesting for Phoenix. Okay. Let's get started. So today we have Paul joining, and he is the lead of OCP test automation lead. Unfortunately, Damon is not able to join, and Paul is going to lead the discussion. Paul, the floor is yours.
Hey, yeah, thanks for inviting me, John. Um, Sorry, I do have the hard stop at around in about 35 minutes, in 30 minutes, so I would have to drop off the call. So yeah,
Yeah,
thank you for giving me the floor first. So if you can make me a presenter, I can share the presentation that
yeah, of
we had
course.
for last year's OCP
So I
Summit.
just stop sharing, then you can go ahead to see if you could
Uh,
share. Do you find the share button over there?
yeah, I think you need to actually make me a presenter.
Oh, really? How? Okay, let me figure out this first time I use this.
Yeah, this app is not the
Okay,
most
I saw it.
intuitive.
I saw it, Paul. So could you try?
Yeah, give me 1 second. I need
Sure.
to actually, I might need to dial back in. This is not good because Mac needs me to actually make the changes.
Hmm.
I'll be right back. Let me restart the application.
Yeah, sure.
Awesome. Can you guys see me, hear me?
Yeah, I do.
Perfect. Hi, folks. My name is Paul. I am the lead, one of the leads for the OCP test and validation project that has been ongoing for about 2 years now in the OCP group. Uh, our goal for this project is to create a framework or testing kind of methodology that consolidates the testing across the industry for all hardware. The reason why this is the case is a few of us got together. We realized that every company has their own framework, has their own way of testing things, has a multitude of different diagnostics that they use, and a bunch of open source stuff. And none of these actually follow a singular convention. So it actually, let me share the presentation that we did at last year's OCP Summit. Okay, this again is not good. Let's see. Um, My apologies. I have to restart the app again. Mac is being difficult with me. But the idea behind the whole situation is that um, we would like to consolidate on a singular standard so that diagnostics become more portable between different companies and different organizations. So, for example, Meta could build a diagnostic and Google could leverage the same diagnostic in their own testing and validation purposes. I will be right back so I can share the presentation. Hang on to your seats.
Okay, it shows up. It showed up.
And I'm talking on mute. Perfect. Sorry about the inconvenience, everyone. So this was the presentation we presented at last year's OCP Summit. It was called Hardware Testing at Hyperscale. So this year we do have some updates to this format and things like that that we will present at the summit in the following weeks. But just to give everyone a brief overview of what we were trying to achieve by having this conversation by launching this project is really we're trying to build a common framework around diagnostics, right? We realized that we were not able to share frameworks because everyone builds their own customized framework for very specific purposes. For example, if you're in manufacturing, you would have shop floor interfaces that you would want, and depending on the vendor, even depending on your vendor you're using, you might have customization in those interfaces. So it's all very different. Or if you're in hardware engineering and you're looking at benchmarking, you might be posting to your internal database for data recording. So you have your own hooks and everything that you've customized those frameworks for. So we realized very quickly we could never share on that level. That's why this project kind of came about, to create a standardized shim layer in between a lot of different diagnostics so that they're easily acceptable and consumable by anyone in the industry. So last year I presented this along with Vincent and Dan. Vincent's from Meta, Dan is from Google. And we talked about really the early days of DC hardware testing, what it was like. It was very different, right? Servers were a very insignificant fraction of what they are today. In the data center, the number of servers in the data center was much lesser than compared to the hyperscalers are implementing now. There's very little variation, right? A lot of it were designed in-house. There were no right now we have like thousands and thousands of SKUs that we have to deal with as a company. Whereas back in the day, there was one motherboard, and everything else was being handled by one singular kind of implementation in-house. But today we enter the hyperscale era, and machine counts have definitely exceeded the linear growth rate. We've grown exponentially over the last couple of years. The types of machines that we deal with are different, right? Now, instead of having a server in the data center, you have a storage server, you have a compute server, you have a now recently you have more AI, ML driven kind of technologies, right? So they're all built on different technologies that, they use RISC for ARM servers, you have x86 for Intel and AMD. It's no longer CPU centric, right? Like I said earlier, there are storage servers, there are accelerators that we deal with today, whether it's TPUs or, whatever CUDA technology we're using. DC designs are now, much more partnerships, right? We have colos, we have things like data centers that are sharing, companies, hyperscalers that are sharing designs, right? OCP is a good representation of that. And a lot of diagnostics are, because of that, a lot of diagnostics are no longer built in-house, right? Some of them are starting to be shared externally. Some of them, there many of them we absorb from the vendors or things like that. So, and that's the kind of important here is the NPI cycle is shortened, right? We kind of have we want to reduce the time to market, and over the last couple of decades, we've actually improved the supply chain to a point where NPI cycles are much shorter than they used to be in the past. So the time for reaction is actually much shorter comparatively. The next couple of slides just go through different kind of areas in which we kind of talk about why, what, who, where, how are these players that actually do diagnostics for hardware. So where it's hardware bring up, it's system integration testing, it's reliability testing. Every one of these players, right? Manufacturing, data center operations, and anyone that's doing a RMA process or reverse logistic process, right? When you're returning the hardware. All of these people use diagnostics to qualify their equipment. They also use diagnostics to kind of measure, benchmark, figure out performance of their systems, and and whether it's a software or hardware diagnostic, both, not these players actually use diagnostics somehow one way or the other. So again, back to what I said earlier, we have different execution environments, right? So we have many test executives and sequencers that whether it's Google or Meta or any other company like Keysight has their own. Everyone has their own test executive and sequencer that they use for different scenarios. Each of these players in this space, they probably have their own framework. For example, even within the same company, these individual players might have their own frameworks, and that's pretty evident in some of the hyperscalers, right? So what ends up is a diverging kind of diagnostic methodology between all of these players. Someone might use YAML, someone might use JSON, someone might use something else, right? Someone might use a text file somewhere to upload the diagnostic data, or someone might create a diagnostic in C, someone might create this diagnostic in Python, someone might work on a bunch of different types of diagnostics, and so we have this large varying pool of different flavors of diagnostics with different markup text, different types of languages, different types of environments that we're executing in, right? But we're actually all doing very similar things, which is basically there's a bunch of use cases that we want to run diagnostics for, right? We want to measure either the performance of the product, the reliability of the product, right? We want to run a long-standing test to see, what is the burn-in life cycle of a product, or what's the infant mortality rate of a product. All those kind of things, they're very common throughout any of these use cases and scenarios. But because of the underlying fundamental difference between frameworks, we end up having to rewrite diagnostic multiple times. We end up having different diagnostics for the same purpose. So it really led to a question of like, what are the challenges that we want to solve for, right? We want to accelerate and reuse the diagnostic across the product lifecycle, right? We want the diagnostic to be portable across multiple products and environments and use cases. Also importantly, we want the reproduction of these tests to be accurate across different hardwares and software partners. So, if one person runs the diagnostic, the other person runs the same diagnostic, you get the same result, right? Rather than person A running a different diagnostic for person B, and you end up having very separate results, and you can't correlate those answers. And that leads to the fourth point on this one, is to be able to share the diagnostics between component vendors and manufacturers to kind of accelerate the RMA and root cause analysis of this. Many times you'll end up in a situation where the manufacturer might be running a diagnostic, doesn't see the problem. You come in-house, we're running a diagnostic that we've built, and then we find the problem, but then we aren't able to communicate that back to the vendor because they don't have access to our diagnostics. So we're trying to bridge that gap. So this one just talks about the different stages of a hardware lifecycle product. So basically, we walk through different. It's pretty common across many players that we all enter a EVT, DVT, PVT, and then a mass production cycle. These are just different stages where we use and just kind of quantifying it for the public, like how many units are usually there, right? We usually go around 10 units per POC, then EVT goes to like 100. The scale significantly goes much larger as we head towards mass production. So how we really got to the OCP diagnostic standard, right, is, like I said earlier, we have all of us end up having our own test executive that runs our own environments, and we have these diagnostics. Generally, they follow this format where we have an executive that calls some web services, that they run some web services, and then the diagnostic is a service that executes something, and then you have a handler that handles it and then executes all those tasks on the end dot and returns the result to the test executive. So generally, most executives follow the same format, and they're actually very similar in nature, right? Because for the most part, it's executing a script or a executable on a product, or going into Linux to pull out some data from the sysinfo or anything like that, right? So for the most part, it's a very standardized flow that most people actually follow. So we kind of sat down and thought about how can we fix this problem, right? If everyone has their own test executive, we're never going to standardize on it because, you said, there's too much customization in those areas. So the area that we figured that we can kind of customize on, we can kind of centralize on, is actually how does the diagnostic actually give you an input and an output? Because everyone consumes and gives data in the same methodology, then you're able to consolidate on that methodology. And it's just a simple API call to make sure that that methodology is executed, right? If you think about this in software terms, basically, we structure the API for test and diagnostics, right? So we thought about it, and that was the easiest layer to kind of standardize on. Everyone quickly agreed because everyone saw the same problem. We just can't share diagnostics because there is no common language for diagnostics. Everyone has their own way of communicating, right? Whether it's JSON, or demo or anything like that. So the goal of this project is really to, as of last year, was to provide a data model for diagnostic outputs, APIs to easily produce that output, streamline the results for long-running tests, parameter management, device communication library that would support SSH or anything like that, and a hardware abstraction layer so that you could see different components inside that. So this is a little this is a little dated because this is from last year. We've actually achieved a lot of the stuff in the new specification. So I will link that to the chat so everyone can have a review if you're interested in looking through the new specification that we've reached consensus between all key stakeholders. How does this fit in different environments? This basically provides, it processes inputs, arguments, it provides actual testing, either on or off the unit. I'm sorry about that. Provides a consistent output format and provides pass or fail that can be overridden by a test executive, right? So in your own kind of environment, in your test executive, probably someone runs a test and then, they have some sequence of things that actually executes, typically integrates with some external control system, to either pass the result onto some database or, some sort of thing. So that's what the executive's responsibility really is, right? This just really draws a line in the sand where, what do executives really are responsible for, right? It's a shim layer kind of interfacing between, your shop floor control or, your asset management device in the data center or anything like that, and interacting between the diagnostic, right? So basically, in order to kind of create that layer where the diagnostic can be portable between, let's say an environment between Google and Meta, what we need to do is create a standardized layer where the inputs are being standardized and the outputs are being standardized. So the next couple of slides are really the result model, how the diagnostic really runs through different kind of, so we actually picked JSON as our go-to language format for the markup. So this actually just runs through the JSON structure of how a diagnostic model looks like. So we have a test run with hardware information, we have the software information with different parameters, then breaks it down to different smaller components of like what the test step consists of, the error messages, the diagnostics, the files that we need to input, the measurement thresholds, hardware informations, the type of series. There's a very, very long JSON specification that we spent a lot of time working on between Meta and Google and a few other stakeholders to reach PE to kind of agree on what that format should look like. I will send a link after this presentation for this group to review that, so that if anyone's interested in participating and joining us, feel free to let me know. But the rest of the slide is pretty technical in the sense of it's just going to run through a example of how the test case could look like. And this one in particular is a memory latency test from Google that they actually use the format for. So this is a real world example of it being actually executed and how this format is actually used. So I won't bore everyone on this meeting with these things. This slide deck is actually shared through the OCP group. So, this is all a lot of text and API measurement series. If you're not, if you're interested in finding out more about it, you can reach out to me or Dad, and we'll be able to walk you guys through specifically how this API is being implemented. And like I said earlier, we picked JSON as our language. Because it's highly portable, it's self-describing. We really don't need any metadata for it. For the most part, it's human readable. You can actually read it through it. Visualizations and tools. There are many JSON tools, right? There is a add-on to JSON called JSON-L that actually lets you.
We could leave this one. Yeah.
Yeah. Okay. So I think the rest of the slides are pretty much just going to flow through like the parametric model of it. And I'd like to actually save more time for discussion than to walk through the rest of the presentation. So
yeah, we only have 7 minutes before you need to drop off.
So let me.
Yeah. Any questions from the OSF project members? So I asked some questions. So that presentation was from last year, right? So since last year, what are the changes, and what's your plan for the next step?
Excellent question, Jordan. So the delta, and we will present this at the upcoming OCP summit, is actually we've added more data to the specification. So the specification actually has grown quite significantly since the last year. We tightened up some of the areas where terminology was a little loose between using. These are more like semantics areas where someone might use an uppercase character versus a lowercase character. So we really went down, tightened it up so that the specification can be as airtight as possible, so that everyone can kind of follow to the same specification.
Okay. What about it? So what's the status of the specification? Is it like in alpha or beta status, right?
We actually have so the version 1 of the specification is live. It's actually production for a lot of folks. The version 2 of the specification is what we worked on over the last 6 months, and we kind of tightened, like I said, we tightened up a bunch of the loose areas. The specification actually is done. It's gone through agreement between some of the larger stakeholders, so it's kind of floating around and getting agreement through some of the smaller stakeholders. But our plan is that at OCP Summit, we will announce the launch of the OCP Test and Validation Specification 2.0.
Okay. In next month.
Yep.
Okay, I see. Is this launched under the name of OCP Test Automation Group, or?
This is launched under the OCP Test and Validation Group. So this is owned by no company at this point.
Okay, got it. So what about actual usage in the field? Is it like, do we see some adoptions already?
Yeah, so Google is already moving towards this format. The Meta guys, we've started to move towards this format. So over the next couple of months, we should see more movement towards it. Some other players like HP have kind of agreed to move towards it. Keysight already has an API that supports their 1.0 specification, so I would assume that they would adopt the 2.0. We haven't had the discussion with them yet. And as the 2.0 specification launches, part of it, we are planning to release diagnostics, right? So Google is planning on releasing some diagnostics to the field so that people can actually use diagnostics rather than just the specification itself.
Okay, cool, thanks. So another area I want to discuss with you is what OSF project and test automation project, which areas we should be able to collaborate?
That is a good question. And I also would pose that same question to the team here. What are the areas that you guys feel like we can help you guys with? I think the specification allows us to kind of interface with, one of the areas that we've been looking at is redfish, right? And how do we innovate better with redfish?
Right, you are talking about schema development, right?
That's correct.
Right. Okay. Any other comments from the team? I have two potential areas we might be able to collaborate. One is the OCP demo lab, community lab. So like you have the framework, and it would be a lot easier for people to know what it really is if it is running in the OCP demo lab. Right. And actually, from the vendor's viewpoint, actually one thing I really like what you guys have been doing is that from the vendor's viewpoint, vendor actually wanted to meet hyperscalers' needs, but often the time they don't know how, because different hyperscalers would have different requirements. Sometimes requirements is not specified upfront, and it's fluid. So the OCP test automation project actually, I think, will play a big part in this. Is that the test automation method getting more unified, and then how to test, and the requirements also like a large percentage of the requirement from different hyperscalers are actually the same, right? Why not make the common part more clear and testable for the vendors?
Yeah, I fully agree. I'm not entirely certain, like, what kind of firmware testing does OSF actually do today, right? Like, you know, how can this be implemented in the software area? I think a lot of focus that we've been looking at is mainly hardware testing at this juncture, because most of the stakeholders here are kind of interested in, you know, manufacturing diagnostics or bringing up diagnostics, right? But we've never really encroached on the area of, like, you know, what kind of firmware testing or anything like that that we've been doing. Can
Right,
we have in this specification, right? So I encourage the group to kind of look through it and approach it from that angle, because that would actually add another flavor to this diagnostic input output, right? I'm not sure that, you know, do we spin off a version of this that's software centric, right? Or do we spin this off a version that, you know, or can we roll that into this current specification? So I strongly encourage the team here to take a look at the specification doc.
Right. So as you said, right, the third area we could collaborate on between the two projects is the firmware diagnostic requirements or best practices, right? Okay. Any other comment from the project members? Okay. Thank you, Paul, for your time.
Thank you, Jonathan. Thanks for having me today.
You're welcome. Thanks for your time. Let's continue the collaboration.
Bye, guys.
Okay. Yeah. So the next topic we want to discuss is the OCP Global Summit. So OCP Global Summit would have many thousands of people joining, a lot of projects. For OSL project, we have our presentations like half day on October, I think 20th, right in the morning. Is it 20th in the morning? So, but OCP provides a good opportunity that for us to like meet person to person and to have discussions. So I want you to figure out how we would be able to find a way to get to know each other and to talk in some topics in depth without getting lost in the like crowds of OCP, right? So one idea is in the experience lab, we actually have a area with 5 tables. So I'm thinking of like setting up like a check-in station at the experience lab of OCP station, so that each people, when we go to OCP, we would go to the OCP OSF station and like sign in. If necessary, put our phone numbers in as well, so that people know how to contact you. So any feedback on this?
I don't think it's a bad idea. I won't be able to attend myself, but Phoenix is planning on sending someone. So I will let them know about it.
Yeah. At this moment, I don't know. So I don't know. So the station will be in the experience center area. So it should be, it will be easy to find. Okay. Um, that's great, Richard. If you can let the people from Phoenix who join OCP know about this. Out of from the audience here, who will join OCP Summit? Who plan to join OCP Summit? Don't I think you will, right?
Yes, and I just sent an email. We have Jeff and Sam are going to be there as well from
Right. So Jay, I think you will join.
Yeah, I'll be there.
Okay. Um, from Intel, Nat and Vincent, will you guys join?
Well, I'm presenting, Jonathan.
Sure. You are not the remote, right? Remote presentation. Some people do.
Yes, I will be
Yeah.
present.
Okay.
But I have to fly back the same day, so I'll have to leave around 4.
Are you saying that you will only be there on October 20th morning and then early afternoon?
Yeah, I'm flying in. I'll get in at 8 a.m. and then I'll go to the convention center, and then
Okay.
I've got to fly out at 4:30.
Okay. Okay. Mhm.
You have a lot of trust in the airline.
Well, it's the Intel airline, so it's fine.
Oh, okay, yeah.
We just need to walk to it. Vincent, will you be able to join the OCP summit?
Probably not. A couple Fridays ago, I went to Santa Clara. I took the Intel shuttle, but since I live in Seattle, I have to like leave home at 1 a.m. and I get home at 11 p.m. So I
Right.
don't think my old body can do another one of those 24-hour days. But yeah, I'll probably have to miss it. Sorry to miss you guys.
Yeah. I really wanted to talk to you, Vincent. So do we have any? So we are able to get a table during October 19th noon time, just for the OSF project for the launch time. So we could have some structured discussions and also unstructured discussions. So I wonder if you guys have any ideas about what kind of topic you would want to be discussed, right? Even if you're not there, we will make sure the topic gets discussed and you know what was discussed. Any potential topics? One topic I know that I was able to see people's presentations, and I see that Microsoft is really very keen at making boot time even more faster. So I think that's a topic we would want to discuss, and especially if Microsoft is over there. But I don't know who from Microsoft will be there. Any other topic we want to discuss during OCP? Think about this. If there's any topic you think is useful, it would be good to send it to the mailing list, and then we can do some discussions through the emails first before we meet at the OCP summit. Okay, so move on to the next topic. Is about the experience lab. So we will have 5 tables. We will have one station, 5 tables. At this moment, we will have Ampere, Super Macro, and Win-Win have demos. So any other company, if they want to do demo, it's still possible because we have 5 tables. You just need to make sure and the request is raised as early as possible because we have to figure out like a power and other arrangements. We need to do all those arrangements.
Yeah, I think Jeff is going to work with the Ampere team for some of his demos.
Jeff from ARM, right?
Right, correct.
So what type of demo does he want to do?
I don't know. I think it relates to some of the work that he has been doing for OSF, and it's not going to take too much space, I don't think.
Okay, yeah.
It's basically his laptop and possibly some Raspberry Pi devices.
Right. I got you. Okay, so that we should be able to accommodate.
Yeah, it shouldn't be a problem.
Yeah. Okay.
I just got his travel approved. So
Okay,
that's the
very
main problem.
Very nice. If there's any needs or questions from him, he's welcome to touch base with us.
Yes, yeah, I have asked him to do that.
Yeah. Any other discussions about Experience Lab? Okay. Okay. So then we move on to the next topic is OSFC 2022 recap. Chris is not here. So let me see. Oh, we just have one more person joined. How to pronounce the name? Andoni or Andone?
Yes, Adonai.
Adona. Adona, which company are you from?
AMI.
Oh, okay. Okay, nice to meet you.
Nice to meet you too.
Are you able to see the sharing of the meeting minutes?
Do I get the meeting minutes from this call?
Yeah.
Yeah, I always do. Yeah, yeah.
Okay, you are able to. Okay, good. So this link, right? It's read only to like to the public. So we already went through some topics, so you missed them. I just want to let you know that we have the meeting minute captured
Sounds good.
most of the points. So if you have any questions, let us know. So now we
Sounds
are
good.
talking about the OSFC 2022. By looking at the list, I think I'm probably the only one who really joined in person. So there's a large crowd, like 170 people around. That's my guess. In Sweden, the biggest crowds are from companies like Nine Elements, Google. Like 20 people from Google joined, from like a Google server side and Chromebook side and Android side mostly. And then we have good representation from AMD joined, and Amazon, two guys. So that's what I remembered. The meeting was and several people from ARM as well. Um, there are the presentations are these 2-day events. So the presentations are on the osfc.io website. I don't think that the video might be posted. It will take some time to be posted. If anyone wants to know a particular topic about OSFC, please let us know. We will figure out how to get the details. Another thing is there is an organization called OSF Foundation that's created. I think OSF Foundation is trying to position itself to help out with all the OSF software projects. So, for example, like a corporate Linux, they might consider to join OSF Foundation in addition to Linux Foundation. Yeah, I joined from the middle side. Okay. Any other question about OSFC? Yeah. Maybe in the coming years, we would have some collaborations with OSF Foundation and some presentations at OSFC. Hopefully, that would be another thing OSF project could work on. Okay. Any other topics do we want to discuss today? Any topics would be interesting to be discussed in the coming meetings? Okay. Anytime when you think of any ideas, this we could just discuss in the mailing list. Okay. Thank you, everybody.
Have a good day.
Have a good day, Ned.
Thanks. Bye.
Okay, bye.
Bye.
Okay, bye.